In this video, we'll look at how to use MATLAB to solve systems of linear equations. This comes up in the real world a lot more frequently than you might think because it's something that we learned way back in an early algebra class. So let's review real quick. What do we mean by systems of equations, or a system of linear equations? So here I have two equations, both with x and y. This is two equations with two variables, which means we might be able to find a unique solution. Not necessarily. Remember, sometimes the solution is an entire line full of numbers if one equation was a multiple of the other. I don't think that's true in this case because we have x and we have x. We have positive 2y and negative y. So the key here to use MATLAB to solve this is to recognize that the left-hand sides are actually, they can be represented as the result of matrix multiplication. If I pull out the x and y and make an xy vector, then what's left is a matrix containing all the coefficients. So here it is for you. This matrix has all the coefficients, and this matrix has all the variables. This is going to make it really easy to solve using matrix algebra. So let's look at how to do that in MATLAB. Switch back over to MATLAB and let me paste in a little sentence here. The left-hand side, so I'm just going to always write them with the variable parts on the left-hand side, and that is going to be, it's going to consist of two parts, the coefficient matrix and the variable matrix. So let's look at this is the same example that we just were looking at. X plus 2y equals 12, x minus y equals -1. So the right-hand side of the equation is going to be its own vector, and that's like our answer. So let's create the coefficient matrix. I'll call this A. By tradition, this is always called A, and by tradition, the responses, the right-hand side of the equation is always called B. So this is going to be just the coefficients exactly as you see them. 1, 2, 1, -1. That's what I need here. 1, 2, 1, -1. Okay? We can look at it if you like. Let's run this section real quick. You see them in exactly the right order. 1, 2, 1, -1. And then we have the answers. The answers are their own matrix called B. And I'll create that. Notice it's going to be a column vector. So 12, semicolon, -1. Okay? So create as a column vector. Column vector. So what we have here, if we imagine the unknowns, I'll call it capital X, and it consists of x and y. The variables that are called x and y in the equation, in this equation, x and y together make up all my unknowns, and I'm calling that capital X here in MATLAB. So unknowns are called. Now what we have is an equation A times X equals B. Okay, and they're matrices. A is a matrix, X is a matrix that's a different size, and B is a matrix that's a different size. What I need to do to cancel out the A is multiply on the left by something that will get rid of A. That's why we need the inverses. If A has an inverse, A to the -1 power, that's the name of it, then multiply on both sides of the equation by it on the left. Remember, with matrix multiplication, you have to specify, are you multiplying on the left or the right? Then we get A to the -1 power times A times X. And that's going to equal A to the -1 power times B. Matrix multiplication is not commutative, but it is associative, which means we can do this first instead of having to do this first, and that means we know exactly what we're going to get on the left-hand side of the equation, because the identity is the matrix that when you the inverse is the matrix that when you multiply by it, you get the identity. So that's going to cancel out, and we're going to get identity matrix times X equals A inverse times B. And we know what the identity times X is. So notice this is all in comments. I'm just showing you why this works, what we're going to do. This is like the algebra behind it. A to the negative 1 power, that's A inverse times B. So to find X, just multiply B on the left by A inverse. That's what we're going to do. So that's all the behind the scenes, the algebra that makes this work. All MATLAB needs to know is I'm multiplying by the inverse. This is, by the way, this is the equivalent of if I had 5x equals, I'm going to use a lowercase x for scalar, 5x equals, I don't know, 75. What would I do? Well, you could say divide by 5, or you could say multiply by 1/5. When I multiply by 1/5 on both sides, I get 1/5 times 5 times x equals 1/5 times 75, which gives me x equals whatever 1/5 of 75 is. So all the calculation you need to do is the 1/5 times 75, which is 15. But that's what we're going to ask MATLAB. X, capital X, equals A inverse, which I don't know if it exists, but I hope it does, times B. Right? Because I defined A to be the coefficient matrix, and B are the right-hand side of the equation, 12 and negative 1. A to the negative 1, if it exists, then it will have an inverse times B. And go ahead and show me what this is. Run section. And we get, it's fractions, but let's format rational just so that we can see the fractions real quick. 10/3 and 13/3. So if I plug those x, and it's always going to be in the order x, y, because we're following along the order that we had here, right? So you just need to know that that's going to be in that order. The first number is x, the second number is y. If you plug them back into the equation, you can check to make sure. We can do that in MATLAB by saying what's a times x? And we get our 12 and negative 1, which was b. All right. We'll do another video a little bit later where we have an example of where this might be useful, but now you can see all of the algebra behind this very simple solution. X is A inverse times B. See you next time.